Welcome to Tomorrow Unveiled. This past week, wow, the world of robotics has just been absolutely buzzing.
It really has.
We're seeing breakthroughs that are genuinely shaping our future. I mean, forget the science fiction for a moment.
Hmm.
We're talking real, tangible advancements, uh, pushing humanoid robots out of the lab.
Right, into practical, sort of everyday deployment.
Exactly. So our mission today really is to dive deep into these developments. We want to focus on what's consistent across the different sources our team looked at.
Yeah, give you clear, concise, but also really interesting overview of this humanoid robotics revolution that's happening.
And our dedicated research team, they've pulled together quite the stack of
Oh
sources.
yeah, everything from academic papers, company announcements, the lot, all published really recently between July 1st and July 8th, 2025.
So super current stuff.
Absolutely. And we'll explore the big hardware and AI breakthroughs, see how these robots are actually performing out in the wild, and talk about what it all means for, the near future.
And trust me, we've got some fascinating things lined up. We're going to unpack, well, a pretty significant reality check for one of the most talked about humanoid robots out there.
That's a big one.
Yeah. Then we'll discover this new class of robots they're calling superhumanoids.
Intriguing name.
Isn't it? And we'll even peek into the slightly strange but fascinating world of robot football tournaments.
Can't wait for that. We'll also look at the incredible AI advances giving these machines their actual brains.
Right.
And what widespread use might mean for industries like manufacturing, logistics. It feels like a real pivot point,
Right.
moving from just prototypes to...
To production reality, or at least the attempt at it.
Exactly.
So let's kick things off with what feels like the biggest story this week. It kind of casts a shadow over the whole industry, doesn't it?
You mean the Tesla Optimus program?
Yeah, that strategic pause. What exactly is going on there? Our research team dug into this quite a bit.
They did. Well, multiple sources are confirming a temporary halt. It's specifically in procuring parts for Optimus production.
Okay, a halt in parts. When did this start?
Looks like mid-June,
Mm.
and it's expected to last about 2 months, maybe a bit longer.
And the
It's
reason.
all to facilitate a pretty significant redesign of the robot itself.
This sounds like more than just, a minor adjustment, this Optimus pause. It seems to reveal some pretty major hurdles.
It really does.
How does this reality check, as you called it, change the game for everyone else in the humanoid space, not just Tesla?
That's a really crucial question. This pause, it's being described across the board as a kind of necessary reckoning.
A reckoning. Strong word.
It is. And it's needed to address some really fundamental hardware problems.
Mhm.
It just highlights starkly that the mechanical and electrical engineering challenges here are incredibly complex. We're not just talking software bugs.
Okay, like what specifically?
Well, things like joint actuators getting too hot.
Ah, overheating. So they can't work continuously.
Precisely. Then there are the dexterous hands,
Hmm?
a key selling point. Turns out they have low durability, and they can't actually lift enough weight.
Not ideal for factory work.
Not at all. Also, key transmission components need a redesign for longer operational life. And the battery, well, it's just not up to snuff for sustained, untethered work.
These sound like deep engineering issues, not quick fixes.
Exactly. They're not software patches. This really reinforces for the whole industry just how hard scaling production of these complex humanoids is. It's like hitting a manufacturing wall, as some sources put it.
And this whole strategic rething, it lines up with a big leadership change too, right?
Yes, that's another key piece. Milan Kovac, who was originally heading up the Optimus project, he's out.
Okay.
And his responsibilities, they've been handed over to Ashok Elaswamy.
Swami, he's the VP of AI software, right? The main architect for full self-driving.
Yeah, that's the one. So now he oversees the entire robotics program, which, really underscores a renewed focus on AI integration.
Makes sense.
And the word is the latest Optimus will feature voice interaction powered by Grok AI.
Interesting. But the implications for production seem, well, pretty stark.
They are. Those really ambitious targets for 2025, 2026,
Yeah.
5,000 units next year, 50,000 the year after.
Yeah.
They now look highly improbable. It's a real sobering moment. Shows how much harder mass production is compared to just showing off a cool prototype.
Definitely a reality check.
Yeah.
But while Tesla's hitting this pause, there's another trend emerging, right? Something about superhumanoids.
Yes, exactly. It's a parallel and I think equally significant trend, the development of what some companies are specifically calling superhumanoids.
Okay, break that down. What are they?
These are specialized industrial-grade robots. They use a humanoid form factor, but they're designed to actually exceed human capabilities in specific ways.
Exceed human capabilities. So this superhumanoid idea, it sounds like a big strategic pivot. Does this mean the industry maybe kind of overestimated how quickly we'd get truly general-purpose humanoids? Or is it more like an evolutionary step?
I think it's largely a pragmatic response.
Yeah.
Reacting to immediate market demands, the dream of that universal do-anything humanoid.
Yeah.
That might still be the long-term goal, sure.
But for now.
But for right now, the clear commercial path seems to be these specialized, high-value industrial tasks.
Gotcha. Any examples?
Yeah, actually. Nimble Robotics, they just announced this week, July 8th, that they've picked PTC's cloud platforms, Onshape and Arena,
Okay.
and they're using them specifically to scale up development of their superhumanoid mobile manipulator robots.
That specific phrase again?
Yep. And these are aimed squarely at warehouse tasks, picking, packing, sorting. Their CEO even said explicitly, this is a critical step as we scale manufacturing and R&D to get rid of bottlenecks.
So these aren't trying to be jacks of all trades. They're purpose-built machines.
Exactly. Built to outperform humans in specific industrial areas, strength, speed, endurance, whatever it might be. But crucially, they can still slide into existing human-centric infrastructure. No need to redesign the whole warehouse.
That makes sense. Are other companies jumping on the superhumanoid train?
It seems so. Dexterity AI, for instance, they use the term superhumanoid for their mech robot. It's a mobile manipulator, 2 really powerful arms. Designed for superhuman strength, apparently it can lift up to 130 pounds.
Wow, okay. For logistics, I assume.
Yep, logistics. And then you have Apptronic's subsidiary, Elevate Robotics. They're also focused on superhuman industrial automation, heavy-duty tasks. It really highlights this shift towards, let's say, industrial discipline and manufacturing foresight that's gaining ground.
Okay, so we've covered the physical challenges, the hardware redesigns, this rise of specialized superhumanoids. What about the intelligence, the AI driving these things? What's the latest there?
Well, our research highlights something genuinely foundational happening in AI understanding, a real leap, moving from just syntax to actual semantics.
Syntax to semantics. What does that mean in practice?
Okay, think about those transformer models, the large language models everyone talks about. Research is showing this fundamental phase transition in how they learn. It's really fascinating. Initially, they just focus on superficial patterns, the structure of language, the syntax.
Or grammar rules?
Exactly. But then, after they process a critical amount of data, something flips. They suddenly shift to understanding semantic meaning, contextual relationships. They start building an internal representation of what things actually mean.
Whoa, it's like they suddenly get it.
Kind of. The analogy used in some papers is like water suddenly turning into steam. A complete change in state. It's not just gradual improvement, it's a qualitative shift.
That's incredible. So a robot equipped with this kind of post-transition AI, it wouldn't just be following step-by-step instructions.
Precisely. Imagine giving it a high-level command, something vague like, tidy up this workshop.
Okay.
A robot with this deeper understanding could potentially generate its own novel plan to achieve that goal. It could reason about the task much more like a human would.
That feels like a game changer for general-purpose robotics.
It really does. And it suggests that a lot of future progress in robotics will come from scaling up these large, multimodal foundation models, giving robots not just skills, but a deeper, more human-like grasp of their world and what needs doing.
So while those big models are learning to understand the world, there's also work happening on teaching robots specific physical skills more effectively. What's this new curriculum for dexterity our team found?
Right, that's another really interesting angle. Our research identified this new embodied AI framework. It's specifically for teaching complex, tactile-based industrial skills.
Tactile-based, like tasks needing a sense of touch.
Exactly. Delicate assembly, precision fitting, that sort of thing. And the inspiration actually comes from human vocational training programs. It's designed to move beyond just endless brute force trial and error learning.
Okay, this tactile skills framework sounds really promising for teaching robots how to actually use those fancy hands. How does it work? What's the clever bit that helps them learn these tricky skills so well?
Well, the core idea is structure. It uses a structured taxonomy, like a classification system, with process specifications defined by human experts.
Ah, so expert knowledge is baked in.
Yes, combined with a library of reusable, low-level tactile control components. Think of it like giving the robot building blocks for skills, along with a really detailed instruction manual or curriculum, rather than just dumping raw data on it and hoping for the best.
A structured approach. And how well does it work?
The results reported are pretty impressive. Nearly 100% success on 28 different complex industrial tasks, things like precision cutting, delicate insertions, even when there were variations in the setup.
Wow, 100% is, well, perfect.
Close to it, yeah. And apparently, it dramatically speeds up the learning process and makes the robot's performance much more reliable. This really tackles what's often called the last mile problem in manipulation.
Getting those sophisticated hands to actually be useful quickly.
Exactly. It's a really powerful hybrid approach, blending that expert human knowledge with the learning power of AI.
Okay, those are some big foundational shifts. Were there other specific AI advances this week that our research team flagged as particularly noteworthy?
Yeah, a few others definitely stood out. There's something called LeverEb out of Berkeley AI.
Liver arb.
Yep, it's a latent vision language action model. Basically, it helps humanoids control their whole body using both vision and language understanding. And it's showing really strong results in generalization and spatial reasoning, like 80% success on complex navigation tasks.
80% is pretty solid for navigation. What else?
Then there's Google's Gemini Robotics on device. The key thing here is on device.
Meaning the processing happens right on the robot.
Exactly. Which enhances autonomy because it doesn't rely on the cloud for everything. It means lower latency, faster response is crucial for dexterity, and generalizing tasks quickly. They tested across like 50 to 100 different demos.
Local processing for faster reactions makes sense. And what about that MIT radar breakthrough? That sounded potentially game-changing. Seeing through walls.
It's pretty wild stuff. They've developed radar imaging that achieve 96% accuracy in detecting hidden objects.
96%. Hidden objects.
Yeah. So potentially, this could allow humanoids to perceive things through walls or behind clutter in really messy environments. Imagine the possibilities for search and rescue, or maybe just navigating a complex, crowded factory floor.
That really could change how robots perceive and interact with the world.
Okay, so it's one thing to see these advances in the lab reports, right? But what happens when these robots face the real world? The ultimate test. And this past week, we got a really transparent look with that Beijing RoboLeague. What exactly was that event?
Right, the robot football. So on June 28th, Beijing hosted China's first fully autonomous 3-on-3 AI robot football tournament.
Fully autonomous.
Completely. This was key. No humans pulling strings with remote controls. The robots had to perceive the field, the ball, the other robots, make decisions, strategize, and act entirely on their own.
They used standardized humanoids, the Booster Robotics T1 model. And this whole thing was basically a public trial run for the big World Humanoid Robot Games coming up in Beijing this August.
Robot football tournaments. I love it. Okay, so what were the big takeaways? What were they good at, and where did they stumble?
Well, some capabilities were genuinely impressive. Their onboard computer vision, for example. Yeah. They could detect the ball from over 65 feet away with reportedly over 90% accuracy.
That's pretty good eyesight.
It is. And they showed real-time decision-making, figuring out when to walk, run, attempt a kick, even some basic coordination between the three robots on a team.
Okay, so the AI side showed promise.
Definitely. But the event was also incredibly transparent about the limitations.
Yeah.
The physical movement was often described as, well, awkward.
Awkward how?
Like 5- or 6-year-old children was one description. They fell down a lot.
Oh, dear. Did they get back up?
That was another issue. Some robots, when they fell, couldn't self-right. They actually had to be carried off the field by humans.
Ugh. That really highlights the difficulty of just stable walking, doesn't it?
Immense difficulty.
Yeah.
Robust bipedal locomotion is still a huge hardware challenge.
And the strategies were pretty simple, too, mostly just chasing the ball, not complex passing plays or anything. Like kids' soccer, really.
You know, it's fascinating about things like this, these public competitions, is they strip away all the marketing hype, right?
Italy.
You get a raw, honest look at where things really stand. The successes show that AI is progressing rapidly, no doubt. But the failures, especially the falls, they shout that stable, graceful walking and running on 2 legs is still, fundamentally, a largely unsolved hardware problem. It's the ultimate proving ground.
Couldn't agree more. And beyond the football, other practical prototypes popped up this week, too.
Oh, yeah.
Manurai Robotics showed off their 4NE1 Gen 3 robot. It has advanced sensing designed for unstructured environments. They were demonstrating its cognitive abilities for things like navigating factories, aiming for mass market suitability.
Okay, more industrial focus. And then Roboterra's Q5. This one's a service robot, 44 degrees of freedom. Quite complex.
Aimed at
Healthcare, retail, tourism. It has AI dialogue capabilities, and they showed it doing some culinary tasks, believe it or not.
making food. Okay.
And AlphaBot 2, from AI robotics.
Mm.
They demonstrated doing domestic stuff like serving tea, but it's also apparently already deployed in some car factories, plans for airports too. So we are starting to see them move beyond just the lab demos.
It's definitely exciting to see that transition starting. Hey, if you're watching on YouTube and finding this insightful, maybe take just a quick second to like this video, subscribe to Tomorrow Unveiled, and definitely hit that notifications bell so you never miss our updates on the future.
Now, to really get a handle on the unique challenges facing humanoids, it's super helpful to compare them to other kinds of robots, specialized ones.
Good point.
Our research this week highlighted some other advances in non-humanoid robots that really put the humanoid challenge into perspective. It sheds light on what we might call the humanoid's burden of generality.
The burden of generality. I like that phrase. So what examples are we talking about?
Well, take Boston Dynamics Bot, the four-legged robot.
Yes, Spot the dog bot.
Right. It's being used up in Scotland for precision agriculture, interestingly. Enabled by portable private 5G networks so it can stream data in real time from the fields.
And the advantage there is?
Superior stability and agility, especially on uneven ground. Something those humanoid football players were clearly struggling with. 4 legs are just inherently more stable than 2 for that kind of terrain.
Makes sense. Any others?
Then there's this fascinating thing from Caltech called ATMO.
ATMO.
Yeah, it stands for Aerially Transforming Morphobot.
Whoa, okay. What does it do?
It can actually transform midair from a quadcopter drone into a wheeled rover.
Get out! Seriously?
Seriously, so it can fly over obstacles, then land and drive across terrain. It offers this incredible versatility for complex environments where you might need both flying and driving.
That's amazing. So when you put humanoids next to Spot or ATMO,
The trade-off becomes really clear, doesn't it? Spot and ATMO offer these elegant, very effective solutions to specific mobility problems. Stability on rough ground, getting past obstacles.
right?
But humanoids, they're tackling a much harder, much more general problem. The goal is to operate in basically any environment that was designed for humans, using human tools, crucially, without needing major infrastructure changes.
That's the burden of generality.
Exactly, and it comes at a price. You sacrifice some of that specialized efficiency and robustness, which we saw pretty clearly in the Beijing tournament. So, this comparison, it feels like it highlights a fundamental design philosophy difference, right? Companies going for universal humanoids are playing a different, maybe much harder game than those building specialized bots like Spot or ATMO.
Absolutely. And this week's developments, especially the Optimus pause and the rise of superhumanoids, show that this strategic question is being actively wrestled with right now.
Yeah. Does the huge potential value of that no infrastructure change adaptability
Right.
ultimately outweigh the better performance and reliability you get from specialized robots for specific tasks?
That's the multi-billion-dollar question, isn't it?
It really is. And the market's still trying to figure out the answer.
Hey, if you're listening to Tomorrow Unveiled on a podcast service, maybe Apple Podcasts or Spotify, we'd be incredibly grateful if you could take a moment to leave us a rating and review. It genuinely helps us reach new listeners interested in this stuff.
So pulling all this together, what does it mean for actual applications? Where are we likely to see these machines making an impact first? Our research points pretty clearly in one direction, at least initially.
Yeah, the overwhelming consensus from the research our team gathered is that factories and warehouses, they're going to be the primary proving grounds, at least in the near to midterm.
Right. We're not talking about personal butlers in every home just yet.
Not quite yet. The big targets are logistics. Picking, packing, sorting pallets, moving things around.
All that warehouse work.
Exactly. And manufacturing and assembly. Think about Tesla's original goal for Optimus on the car assembly lines. These are jobs that are often repetitive, physically demanding, and frankly, often have high staff turnover.
Which brings us to the economics. That's paramount here.
Absolutely. For these things to be adopted widely, they have to be cheaper than the total cost of a human work, wages, benefits, training, everything.
Or they need to offer some kind of unmatched productivity or precision that justifies the cost.
And what are the costs looking like now?
Well, current costs are still largely prospective. We hear figures like $60,000 per unit now, but companies are aiming to get that down, way down, maybe eventually towards $20,000.
But achieving that
Depends entirely on cracking those manufacturing and reliability challenges, the exact kind of hurdles that seem to be behind the Optimus pause.
So connecting the dots here, it feels like the road ahead, moving from all the hype to actually having a viable robotic workforce. It hinges on this convergence, right? AI and hardware finally meeting in the middle.
That's a great way to put it. Success really depends on closing that gap between having robust, reliable physical platforms, and these increasingly powerful, semantically aware AI models we talked about.
And that tension, the AI seems to be racing ahead while the hardware engineering is, well, hard and takes time. That feels like the main source of unpredictability right now.
I agree. And we'll likely see this continued battle, or maybe interplay, between specialization and generalization play out.
You mean the superhumanoids versus the general purpose ones?
Exactly. Will those specialized superhumanoids capture the immediate market for specific tasks? Or will the general-purpose robots eventually mature and deliver on that universal promise? That strategic question is probably going to define the market for the next, say, 3 to 5 years.
Another factor our research highlighted is the data moat.
Ah, yes, the data advantage.
Explain that.
Well, the companies that manage to deploy robots first, even in limited numbers, they'll start collecting vast amounts of unique, proprietary data about physical interaction in the real world.
Data on how to actually do things.
Exactly. How to handle objects, navigate clutter, recover from errors. And this data becomes incredibly valuable for training better AI models. It creates a powerful flywheel effect. Better data leads to better AI, which leads to better robot performance, which allows more deployment, generating even more data.
Giving those early movers a significant competitive advantage.
Potentially a huge one.
Yeah.
And it signals a shift in how we measure success in this field.
How so?
The industry seems to be moving away from just flashy demos. The backflips, the short walks in a controlled lab.
Right, the viral video moments.
Yeah. Now, the real key performance indicators, the KPIs, are becoming things like operational uptime, thermal efficiency, how long components last, and crucially, manufacturing scalability and cost.
It's no longer about what one robot can do for 30 seconds.
Exactly. It's about what a fleet of 1,000 can do reliably, 247, day after day, week after week.
Yeah.
The true rise of the machines, if you want to call it that.
Which we do for this episode.
All right. It won't be measured in YouTube views. It'll be measured in operational logs, maintenance schedules, reliability statistics, and ultimately,
Quarterly earnings reports.
precisely. It feels like the industry is finally really getting down to business.
So summing up this packed week, it really feels like the humanoid robotics revolution is hitting an acceleration point, but also a reality point. Moving beyond just speculation to tackling these tough practical challenges head on.
Definitely. We've seen critical adjustments, like with Optimus manufacturing. We've seen the rise of these specialized superhumanoids finding a potential near-term niche. And we've seen these foundational breakthroughs in AI that promise to make these robots genuinely intelligent.
Yeah, the challenges are still huge, especially on the hardware and reliability side. But the path towards a deployable, reliable robotic workforce, it feels clearer now than maybe ever before.
I think that's right. The goals are becoming more focused, the metrics more grounded.
Which leaves us with a pretty big question, doesn't it? As these robots become more capable, more integrated, first into industry, maybe eventually into our daily lives, how do we adapt?
That's the crucial human side of the equation.
Yeah. Not just adapting our workplaces, but maybe our whole societal expectations around work, perhaps even companionship down the line. The future isn't just being built in labs and factories.
It's being unveiled right before our eyes.
Couldn't have said it better myself. We always love hearing what you think. Whether you're on YouTube or listening via your favorite podcast app, drop a comment. Let us know your thoughts on the future of robotics and this whole rise of the machines.
Yeah, we're really curious to hear your take.
Thank you so much for joining us on this deep dive into the absolute cutting edge of innovation. We'll be back next time on Tomorrow Unveiled, ready to explore whatever tomorrow holds.